Okay, so in this video here we're going to be looking at determinants of a matrix and understanding what is meant by the determinant of a matrix. Okay, so the determinant of a square matrix I'm going to write in brackets here, i.e. 2 by 2, 3 by 3, so on. Okay, is a number associated with the matrix. Okay, so determinants have important applications and properties. Okay, some of which we'll see in future lessons. Okay, so it's got important applications and properties. So how do we denote it? So the determinant of a square matrix A is denoted by the determinant of A, okay, det bracket A, or we can see the magnitude of A. Okay, that's maybe the orientation. You normally see the first one a lot more often. Okay, in a lot of exercises, a lot of textbooks, a lot of past paper questions, you normally see it written det. Okay, so that's how we're going to denote the determinant of A. Okay, so we're going to look at the 2 by 2 case first. Okay, and the 2 by 2 case is actually pretty straightforward. Okay, the 3 by 3 case takes a little bit more work, but we'll see that in a second. Okay, so 2 seconds, come back to that. There we are. Okay, so the determinant of a 2 by 2 matrix is defined as follows. Okay, so if I've got a 2 by 2 matrix, okay, then to get the size of it, so we've got 4 entries, A, B, C, and D. So the determinant of a matrix like this, you multiply A with D, okay, so top left with bottom right, and you subtract the multiply of BC, top right multiplied by bottom left. Okay, so it's A times D minus B times C. Okay, so that's the rule for a 2 by 2 determinant. Okay, we do it like that there. Okay, we'll look at a quick example. Alright, so we're going to find the determinant of 4, 3, negative 1, negative 2. Okay, so what we do is we do 4 times negative 2, subtract 3 times negative 1. Okay, until you get familiar with this bracket, it's maybe useful just to keep you right with your negatives. 4 times negative 2 is negative 8. Then I'll be negative 3, so we're adding 3 onto that, which would be negative 5. Okay, so that would be the determinant of that matrix there. Okay. Are we okay with that? Okay, so that's a 2 by 2 case, and it's literally that all you do. Okay, 2 by 2, that's the rule you use. Okay, so you might want to make sure that you maybe highlight that or put a star around it or something, okay, because that's the rule. Okay. Now the 3 by 3 case, there is a rule, but it's actually easier to show you as an example as opposed to getting all the algebra out. Okay. Basically, you break it down into lots of 2 by 2s. Okay, and I'll show you how to do that. Okay, so for a 3 by 3 case, okay, we'll just go straight into an example to show you how this would work. Okay, so example 2, let's work out the determinant of the matrix 3, 2, -1, 6, -4, 2, -1, 0, and 4. So we're going to work out the determinant of a 3 by 3 matrix like that. Okay, so what we do is we use the top row and split up the second and third. Okay, so what we do is, now the key also is the signs alternate. Okay, so you'll see what I mean by that in a second. Okay, what we do is, well, I'll highlight it for the first one here. I'm going to take my first number in my matrix, okay, the top left corner row. Now what I'm going to do is I am going to use the numbers in row 2 and 3 that is not in the same column as that 3. Okay, so what I'm actually going to do is I'm going to use these numbers here. Okay, it's not in the same column as the 3. Okay, so that would be 3, and I'm going to do 3 lots of the determinant of -4, 2, 0, 4. Okay, so I've actually got a 2 by 2 determinant to work out for that bit there.
Is it important that you do your line like straight lines?
To show that you're doing determinant, yeah, straight lines, so that, yeah. So it's not a new matrix. That's just I'm doing a determinant for those numbers. Okay, right. Then I'm now going to do the second number. Now, when I said signs alternate, I've got to now flip the sign of that second number. Okay, so it's going to be -2. Oh, let me try and write that in the right colour for a start. So that's going to be -2. Let's go back to a blue pen. Now the numbers I'm going to use here is not the same numbers that's in the same column as that. I've got to use the -6, 1. Sorry, the 6 and -1 with the 2 and the 4. Okay, that's going to be the 2 by 2 part there. Okay, it's going to be 6, -1, 2, 4. Okay, then try and find a sort of semi-decent colour on this page here. Last one, it's not the best, is the -1. Okay, keep the sign of that one because I flipped the second one, so I'll keep that one the same. And I'm now doing these numbers in here. Okay, so I know it does look messy once I put all my colours on, but hopefully we've seen the process there. So it's 6, -4, -1, 0. So I've actually got 3 2 by 2 determinants to do here. Okay, that's what I'm going to split up the 3 by 3 case to be. So this first one is going to be 3 lots of. Okay, well, it's going to be -4 times 4. Okay, so remember you do the diagonals, times each other, subtract 2 times 0. Okay, next one's going to be then -2 outside, so it'll be 6 times 4. Take away 2 times -1, and then -1, 6 times 0, subtract -4 times -1. Okay, so do you all see how I got those values in the brackets there, yeah? Just done the rule for the 2 by 2 determinant that we've seen before. Let me just work what's out in each bracket. Okay, so -4 times 4, that gives me -16. -16. Yeah. -16. That's just -16, isn't it? Okay, because 2 times 0 is that. Okay, next one. We've got -2. Okay, 6 times 4 is 24. I'm going to add 2, because 2 times -1, but the 9 hits that, that's going to give me 26. 2 lots of 26.
Thank you.
And next one's -1, and that's going to be hit with -4. Okay, so I've got to deal with that there. So that gives me -48 -52 plus 4, and that gives me -96 if I've done my maths correct. Okay, are we okay with that one there? Alright, so that's how the 3x3 matrix works there. We've got to split them up into 2x2 parts. And remember, your middle one, you always alternate the sign for your middle value in your top row. Okay with that?